welcome to Learn with Jason. Patrick, thank you so much for taking some time to hang out with us today. How are you doing?
I'm doing great. How are you?
I'm doing so good. So for folks who maybe aren't familiar with you and your work, could you just give us a high-level background on who you are and what?
So yeah, my name is Patrick Dubroy. I am an independent programmer and researcher. I'm the maintainer of a library called Ohm.js, which is a library, a parsing toolkit for JavaScript and TypeScript. I am also a co-author of the book WebAssembly from the Ground Up, which is a book about how to learn Wasm by creating a very simple compiler in JavaScript.
And I am very excited to learn how to do, I believe, a subset of exactly that today on the show. So I'm going to go ahead and get us right into our pair programming view here. And I'll just, so here's the website for the book. This is WebAssembly from the Ground Up. And if you want to get a discount on the book, let me put the link up on screen here. You can use the code JASON to get a discount on your purchase of the book. With that, I'm ready to rock. What do we want to do first? What's the first thing we should do to get started?
Okay, so I have like a little something on the site here that you can go to. If you can go, instead of to wasmgroundup.com, beta.wasmgroundup.com.
Beta.
And /JSON. Oh, sorry.
Oh. Ooh, cool. Okay, all right. We're already into a personalized experience. This always makes me happy. Let me make this a little bit bigger so we can see what's going on. All right, What are we looking
at? Well, we're looking at what we call a day in the life of a WebAssembly module. So what I wanted to show you is just, what it can look like to use WebAssembly from just the simplest possible perspective, because I think a very typical way to use WebAssembly is, compiling from some language like C++ or Rust, and you get this sort of big bunch of different files that need to be loaded. And this is really taking away sort of all that complexity and just showing you what the kind of most simple thing you could possibly do with Wasm is. And this is also, though, a good example of like even Figma, they use WebAssembly pretty heavily in their app. It's going to have the same pattern, basically. So there's sort of a core pattern here that you will see in basically every WebAssembly app. So WebAssembly itself, basically you will see these Wasm bundles. So you see the first line there, we fetch add.wasm. If you had some C++ and you compiled it to WebAssembly, it would produce a .wasm file for you, which is a binary encoded set of instructions that your browser or your runtime is going to eventually compile down to native code for your machine.
Okay. All right. That makes sense.
And the next line is basically what needs, this is how in the runtime you turn this bag of bytes into something useful. So you instantiate a WebAssembly module. And that gives us back what's called a module instance, which is actually something very similar to like a module in JavaScript. So it's just a thing which has
we've got exports here, and then we've got functions on the exports.
Yeah. So WebAssembly, like ultimately a WebAssembly module is a thing which can export functions, can export global variables, can import functions, and can run code. And it runs in this sandboxed way such that unless you give it any functions that let it do things, it can't really do much on its own.
Okay. And that's good because that means we can safely do all sorts of things, including, for example, executing arbitrary user code, because it only has access to what we explicitly give it access to. So
Exactly.
unless we really insecure and said like, oh, this module can do anything, now go execute all this user code, you know, obviously you can still get yourself into trouble with anything. But it's kind of nice knowing you by default, it's just going to say, oh, I'm not allowed to do that, instead of saying like, yeah, sure, I'll delete the mainframe.
I mean, yeah, it doesn't even have a way to express many kind of bad things that it could do, right? Like it can't even, you know, it doesn't know the name of your files, so it can't try to delete your files or anything like that. It's basically, so there are, I think in Wasm 1.0, there are 172 different instructions, I believe. Okay. They're basically for doing math. That's, you know, the large majority of the instructions are for doing math. There are some control flow instructions for, you know, doing things like ifs and loops. And it can call into functions that you provide to it. And it can read and write local variables and global variables. But beyond that, it really does not have much power on its own, except the power that you give it.
Got it. So that's good.
Yes. Yeah. And then to just, you know, I think what I wanted to do here is sort of take this apart piece by piece a little bit. Mm-hmm. So you see underneath the code, we have the raw bytes of add.wasm. Mm-hmm. There's I think a little over 40 bytes here. So basically all this module does is there's a function in it called add that can take two parameters and add some, right? To simplify this a bit, so we can represent the same bytes that are shown in that raw bytes text field. We could represent them as a uint8 array in JavaScript. So let's the first thing I'd get you to do would be to copy that that uint8 array, and we're going to actually paste it into the code above.
Paste it in here.
So yeah, where we pass in the response rather than passing in the result of, you can delete that line entirely.
Delete this entirely. Okay.
Yeah, exactly. And then where you call instantiate streaming, we're going to pass that array in. So it just gets rid of the fetch, right? So instead of going to the server and getting some bytes, we're going to say we have the bytes already, and we're going to specify them. I think you will need to change that instantiate streaming to just instantiate, because the streaming version will expect a promise. And
right, because we were doing an await.
Yeah,
but there it goes. Now we're getting the same outcome, so our math still works.
Exactly. Yeah. And then the kind of slightly unhinged premise that we have in our book is that we begin by actually writing these bytes by hand. So, you know, these bytes in here it has special meaning, obviously, to the runtime. There's
so, Patrick, I'm gonna tease you a little bit here, because remember in the companion episode of Web Dev Podcast when I was saying this feels like it's for people who are way deeper in the stack. How you got us writing byte code by hand.
Don't worry, this is as bad as it's going to be, and it's going to get nicer from here.
Okay, all right, I'm with you. So sorry, you start us out in the book by actually having us write these by hand. So I see this link here that says Wasm opcodes. When we're talking about opcodes, can you maybe just demystify a little bit what's happening here? Because I intellectually understand that
Yeah.
programs compile down until there's something that a computer understands, but a human doesn't. And I feel like that's what I'm looking at, right? This is sort of like looking at the matrix. But each of these things has a very distinct meaning. And I guess when you're looking at this, because it's spent so long in here, I assume you are, in fact, kind of seeing matrix.
A little, yeah. It's, yeah.
Okay.
So, yeah, this bag of bytes that we have here actually there's sort of two things. At the highest level, we have a file format that is really just a container for, for instructions. Mm-hmm. And a lot of the stuff that you see here, these are not even actual instructions. They're just the container format. So it's not all that different from something like PNG or JPEG, right? It's a flexible format that lets you put your data inside it, but the format itself kind of dictates, many file formats have what's called a magic number. So the first 4 bytes of the file need to always be a special sequence. And yeah, that is the magic number for Wasm modules. It is the first byte is always 0. And then you have the ASCII code for the letters ASM.
Okay. All right. I've seen ASCII before, so I'm keeping up here, and this is the ASM there.
Exactly.
Got it.
Elsewhere in the module, there is, we have a little bit of text for the function. You see the text add as well, right? Mm-hmm. Somewhere in the, in the middle of the module, we have a declaration. There's a function in here, and we're going to export it, and its exported name is add, which is why we see the text for that. It's only really actually the last 6 or so numbers in that array. So 11 is the opcode for end.
11 is so this is the opcode for end.
So this is the very much seeing the matrix. Yeah, it's that's the end instruction. The 106 there is the add instruction.
Okay.
32. So you see 32 appears twice. It says 32 followed by 0 and then 32 followed by 1. That is to get the value of a local variable. And so 32 is the opcode for local.get. So yeah, normally, you would not want to deal with things at this level. Mm-hmm. What we can do now, you could add if you go up to the source code and add a debugger statement, just type, just debugger. And can you open the DevTools? So we can actually look at this in a much nicer way. The bad part is over.
Let's see. All right. So I'm in here. We're going here. I'm going to run this.
So if you run, we'll hit the debugger, and then you can actually step into that call to add.
Okay. And so here is the step. No, which one of these is step?
No, to the right. You want to step over. Yeah. Okay. And then press the step into, which is the next one to the right here. And we now see a much, much nicer representation of the same things that we were looking at before.
Mm-hmm. And so now I'm seeing, so this was our 32, and this is getting the first variable, which is variable 0. This is the other 32. This is the second variable, 1. And then we call add. Okay, so I'm kind of following here. I'm not I'm not going to pretend that I could write this from scratch, but I'm keeping up at least. Yeah. That feels good. But I also like that over here we can see, you know, the value of variable 1 is 0, the variable var 0 is 3, var 1 is 4, and we can kind of see what's happening. I like this. This is much more human readable to me. I'm into it. Okay.
Cool. Yeah, I mean, I think looking at the raw bytes, right? You know, even we don't do that, but I just kind of think it's fun just to see the connection between, you know, what the browser is going to actually interpret in the end, and you know, the higher level representation.
Right.
So this, I do want to mention, like, this representation that you're seeing here, the text format. So this is, it's called the WebAssembly text format. The browser, the div tools right now are disassembling this for us, which means it has just the raw bytes on disk. But you know, it can turn it into a human readable representation. And
so this isn't what's in the .wasm file. This is the browser sort of doing a reverse translation so that we can read it again.
Yes, exactly.
Okay.
So in a production pipeline, this text format is actually, you know, you would never be using it directly because, you know, your C++ code compiles down to binary WebAssembly. The binary WebAssembly gets shipped to the browser, and the browser is going to work with that. You know, we don't need the text format in any stage of the production pipeline, but as a human, it's very nice to look at it. It's much nicer than looking at a list of numbers. And this, you know, is fairly kind of similar to what assembly language looks like on other platforms. It's slightly higher level, but the differences are pretty subtle. Yeah.
But it's good for, you know, again, like the things that are intimidating about this stuff when I think about it are, you know, okay, so you're compiling your stuff down and then it gets into production, you get a weird bug. Knowing that you have the ability to put a debugger in here and see something that's not just the compiled WASM that you're trying to, you know, like I have enough trouble trying to read minified JavaScript. I'm not going to be able to dive into opcodes. It's not going to work for me. So knowing that the browser is kind of going this extra step of giving you visibility into what's happening and letting you inspect, like, okay, when you got to this call, this is what the values were. That's all I need to be able to debug my code. I can see, oh wait, that's not what it's supposed to be. Let me figure out what I did wrong, and then, you know, I compile it again, run it again, and I get the better outcome. So this immediately makes me less scared of taking WebAssembly on.
Yeah, that's good. And it's even, I mean, some people write apps in this language, actually. So you can write your app if you really want to in the WebAssembly text format.
And somebody's asking, is this Lispy on purpose?
Yeah, I mean, it's I think it was chosen because if you don't want to argue about syntax, Lisp is, well, Lisp fans believe Lisp is sort of the primordial syntax.
Right. And good. Yeah. All right. I'm into it.
And I've heard that basically they proposed this and everyone agreed, like, yeah, we'll come up with something better. But in the end, they never came up with something that they thought was actually better. And there were more important things to do.
Yeah, no, that makes sense. That makes sense. Okay. So we have our basic debugger running. We have some pretty gnarly, just a straight up array of opcodes being fired into this WebAssembly thing. But the fact that this works is extremely cool. And the fact that, you know, there's no additional dependencies here, we just put whatever this is, 100 bytes of opcodes into this WebAssembly call, and we're able to get addition out of that. Pretty neat.
It's pretty cool. Here, there's one more thing we can do. We can actually like change one of those opcodes at the end. Let's change the addition to subtraction, and then we can move on. So if you scroll up to the end of that uint8 array, change the 106 to a 107.
106 to a 107.
Which is subtraction, the subtract instruction. And
so
if you run this,
once I do this, I should expect to see then we're going to get a -1 and a -10 if we're subtracting properly.
Yes.
Very cool. I mean, that's very cool. I love this stuff. This is such a rare treat to like, just, who has time to like dig into the byte code? Not me.
Okay, there's one more thing I want to show you here. Like just delete one of the numbers in the array. Just I kind of want to show why. Yeah. And then run the code again and
out of bounds.
Yeah. So one of the really nice things about working with WebAssembly is there is a validator that basically, if you mess up in, 80% of the ways you can mess up, the validator will catch your error. Mm-hmm. So if we, for example, were to try to add without, having a number, or like if we just had the add instruction and removed those local.get instructions, it would give us an error. Yeah. So, I mean, sometimes you can argue that the errors don't always tell you exactly
they're not
what's
exactly
wrong,
solving problems, but they're at least letting you know that there are problems.
Yeah. Okay, if you scroll up to the top of this page then, so I think we can now move on to the less, sort of the less unhinged stuff.
Okay. And so just to recap, what we've done here is we started with like hard mode. We took a simple addition function that had been compiled into WebAssembly and looked at the raw bytes of the file, which are here, looked at what those would look like if they were converted into a uint8 array in JavaScript, and then we just ran that straight in the browser here by passing in our array, our like, here's our Wasm, pass into this WebAssembly.instantiate, which then lets us run addition, and this is the output of that. So really cool that we were able to do that and that we modify it right in the browser. Like, it's just neat. It's just neat. So this is a compiler in a tweet. I'm scared.
Yeah. Don't worry. I just want to show, this is really more of a party trick. We have this blog post called, a WebAssembly compiler in a tweet. And those first 4 lines, that's the compiler.
That's the whole compiler.
We're going to work with a nicely formatted version of this. So you can click on deobfuscated. And we see something that hopefully is already a lot easier to understand, but we still have this sort of somewhat scary array of bytes, down at the bottom. Mm-hmm. But we at least have something that we didn't have before, which is that we have this insters variable, which is our actual instructions. So we're going to create a module here that has one function again. And that function this time is going to just evaluate an arbitrary arithmetic expression. And we've still got a bunch of kind of nonsense that we need to, use to pack our instructions into a valid WebAssembly module. But, we don't need to worry too much about that. And so there's a even less obfuscated version of this. If you scroll back up to the top, click on that.
Okay.
And
so
then if you,
this is basically
code. Yeah. all this stuff is basically the same. But we have now a bunch of comments which just explain what all these different bytes are in the module.
Right. So we talked about magic number.
Yeah.
And then, okay, so the next one, the version number. Got it. And then we say, this is why we were getting the notes about being out of a range, is because when we were deleting numbers at random, we like it saying this is 5 bytes long, and we were deleting one. So then it was, what do you mean you didn't send me enough bytes? Okay, so now that error message is actually a little more interesting, because before I thought it was, it always just sounds like computer nonsense until you know what the computer nonsense means. But it's good to know. And then, so let me see how far I can get before I get lost here. So we're saying there's a section. So this is section 1. We have 5 bytes in the section. Number of entries that follow, I assume, is referring to this additional function section. And then we're saying that it is a function that takes 0 arguments and returns 1 value of a type integer, or in 32. And the function is a second bar. I don't know what that means. Section size is 2 bytes, 1 additional entry to follow. And I'm guessing that's because it's referring to this one, the index of the type section.
Maybe the comment is a little bit confusing here. These things, each section is basically a vector or an array of something. Okay. The function section is an array of functions. And that's basically, that third number is just the array size. Like, how many functions are there? There's 1. How many type declarations are there?
I get it. So this is saying that, like, the function. Okay, I'm kind of following. Yeah, I'm mostly with you.
Yeah. Then, so basically in the module, there's this kind of clear or well-defined order in which the module, the various sections need to appear. After functions, we have, so the function section is just function declarations. You just say, this is how many functions there are in the module, and this is what their types are. Then we have an export section here, which is where we end up giving the names to any functions that we're exporting. If you scroll down a bit more, we have the code section, which is, I think, the most interesting one. And there will be 1 entry in the code section for every function in our module.
And we're building that manually. And that's up here where we do this. We're looping over each of our.
So
let's see, what are we looping over actually?
Yeah, scroll down to the bottom here and I'll just show you kind of like what the goal here. So you see this expression, like below the code, we have an expression where it says 1, 1, and then plus. So are you familiar with reverse Polish notation?
I know, but okay. I'm assuming we're saying argument, and then what to do with them?
Exactly, yeah. So there was actually, HP used to make these calculators that a lot of engineers really loved, apparently. I mean, it's before my time, but I've heard about this. And they worked in this way where you give argument, and then operator. What's really nice about that is you don't need to use parentheses. So you have, this is what's called the stack model. And this is also the way WebAssembly works. You have this sort of hidden stack. Whenever a number appears, we just push it to the stack. So in the meaning of this expression, 1 space 1 means push a 1 to the stack, push another 1 to the stack. Then the plus will take 2 arguments off the stack and leave 1 argument on the stack.
Okay. So we get in our expression. We split that on spaces. And then we say, if it is a number, then we, this is the opcode for setting it as like int. Is that right?
For basically just for a number. So it's
so we're saying that
I32 const, but that just pushes a number to the stack. And what we're going to do with that, unknown.
Got it. And if it's not a number, we use the opcode based on what type of a we want to do, or we default to addition if somebody puts in nonsense.
Yeah, I don't know why why we default to addition, but we should probably.
My question then is, did I break it because the math is wrong? Good
point. Did you break it? Did you change something here?
I don't think I did, but I don't know. I don't
remember. Do you want to reload the page?
Yeah, let me reload the page. And let's get over to deobfuscated. And it now just wants it to be, what if I added a number?
That's funny.
Is it just giving us back a number? What if I use a different thing? Let's do.
Can you put 3 and 9, 3 and 7 as the
3, 7
and plus?
He's just giving us back the first number.
We must be dropping something here. Well, there's two things we could do. Do you want to look at the deobfuscated version first and just make sure that
oh yeah, good call.
That one has the same.
No, that one's doing the thing. So it must just be some small typo in here.
Yeah, exactly.
And
so
who knows what it is.
So why don't we grab the code from deobfuscated? So the one that works, okay. Unless you want to have a really, hair-pulling debugging session. You can just grab this whole code and we could stick this in a file and start to hack on it.
Yeah, let's do it. Let me get a new window open. We're gonna. Oops, not you. Get out of here. You though. And then I'm gonna. What are we doing? Sure. Where are we? Let me just set up a new folder real quick. We're gonna go into GitHub and. Yeah. And we're going to make a new directory called Wasm. Please stop. Going in here, and then I'm going to open that up. Now we should be in a reasonable place. Let me create a new file. What should I call this file?
Index.js. Whatever you like.
So it's a JavaScript file.
Yeah.
Got it. So we're looking at here's our file. We've got it running, and theoretically speaking, we can execute this in the browser somewhere. You gotta chill.
Yeah.
Okay.
Cool. So what we could do is install, if you want to do a pnpm init, and then install a library that will free us up from ever having to type the raw opcode.
Okay. And okay, so pnpm add.
Yeah, so at Wasm ground up.
Oh wait, let me get init this real quick because it's just Wasm ground up.
At Wasm ground up, like it's namespace.
Got it.
/emit. Emit.
What am I doing? That's not how any of this works. Okay. But I remember how to code. We've got the Wasm ground up installed at version 2.12. Do we need any, like, do we want to add a script to run it, or?
Sure. Yeah. I mean, a test script maybe is nice, like a proper test.
Use the actual tests, and that would do. Do you just run it like node?
Yeah, node -- test, I think, or yeah, whichever. Oh, except node -- test will. Yeah, that should do the trick. I don't think the -- test actually does anything if you specify the file on the command line. But
really, I actually have never used the -- test. I don't know what it does.
It finds test files, basically.
Oh, interesting. Okay.
Like it's
Yeah. All right. I'm into that. So we should.
The thing is, then we would need to have something called like index.test.js or index.spec.js or something. But I think we probably just want to have one source file, and we can just stick the tests at the bottom.
Keep it easier. Yeah. PNPM run test then should give us PNPM run test. Does nothing yet. Because we're missing. What? Did I miss something?
Oh, didn't we just run this and it worked?
I could have sworn we just ran this and it worked, and it's also not complaining.
Do we need type module in package.json? Shouldn't matter.
Oh, I bet we do.
But
there we go.
That looks better.
So that's running. We got our output. We get 2. So because it was trying to run it as CJS, which it didn't like something about that.
Yeah.
I'm not going to stress about that today. We're working. We got a module.
Yeah, sounds good. Cool. So let's see. I mean, we can do an import at the top here, and imports basically the library that we added gives a bunch of nice like constants for opcodes and stuff. So you can implement star as W is the way I like to do it. Yeah.
Okay.
And then we could go and change those opcodes there. So the 106, 107, 108, 109, we could change to i32 w.i32.add. Actually, sorry, that's not quite right. We need to declare a constant at the top of the file, or like just outside of this constant. We need const and then open squiggly instr, INSTR, like short for instruction, equals W.
Equals W.
So, yeah.
Okay.
Just because in the library we have sort of all the instruction opcodes under instr. Yeah. So instr.i32.add.
Okay, and this one's going to be sub, I imagine.
Yep.
And is this molt?
Mol, I believe.
And then I'm guessing div.
And this one's going to be fun.
S or signed or unsigned?
Yeah, that's right.
Okay. Do we care?
I don't think we really do in this case. No, you can probably choose unsigned.
Unsigned.
Yeah.
Okay.
I don't think it's going to matter for us because I don't think we can actually type negative numbers in our code.
That's true.
And we could also fix up our i32.const down below. So where we have 65 there, we can actually do instr.i32.const. And hopefully everything still works.
Let's run it and find out. Works.
Yay. Cool.
Okay. We're cooking here. So this is good.
Yeah.
And then like we can, this one can go back to add, and we start getting some good stuff going here. Starts to make a little more sense.
So we could add like a new operator here. So I don't know.
Yeah,
We could add
what about this guy?
Yeah, sure.
And what is this one called? This is called the mod.
Mod, but I think the instruction is actually called rem for remainder.
Okay, so we'll stick with unsigned.
Should we
okay, so then theoretically speaking, down here, I can do, let's go 5, 3 modulo, and that should give us a 2. So let's, there it goes.
Did you see that?
If I can, I can find my, there it is.
Okay.
So yeah, that did the thing, which is exactly what I wanted. Good.
Cool.
Good.
You just added your first instruction to your brand new compiler.
We've done it. We've kind of dug in here. And so just to kind of recap how this works, because I feel like we went a little bit fast, and I want to repeat it to make sure it sticks in my brain. What we're doing is we're passing in, this is our call. We're saying calculate this expression. And we're using a format that says take a number and then take the next number and then do whatever the instruction is. And so in this case, we can change it to, for example, multiplication, and we should see 15. And if I scroll up, we do. There it is. So this is
and we
is
can
exactly
stack. We could stack more things after that times, right? So it's not restricted to just using one operator. So after that, you could do 2 and plus or 2 and times. So we should get 30 now.
And so this should get us 30. Let's try it.
Because the times is going to take 2 arguments off the stack and then put its result on the stack. And then we push another 2, and then the next multiplication takes those off the stack again.
And what if we do can we do 3 things? So like if I do, for example, 2, 2, 2 plus, that's just going to work, right?
Yes.
Maybe. Oh,
the stack is too big. There's an extra thing on the
expected
stack.
one element bound to. Okay, so we are setting.
We need to consume. No, so it was okay what you have, but the problem is that you never consumed the last thing on the stack. So if you put another plus after this, after the last plus, so if you do 2, 2, 2 plus plus.
Oh, I understand.
Yeah.
God. Right. So now this is like this chaos mode, because it's not the order doesn't matter. Well, the order matters in terms of like the numbers are operated on in order, and the operations are done in order. But the order that the numbers and operators are in the sequence does not matter, as long as there are enough things in the stack by the time the first operator gets hit.
I mean, it matters. It's just not obvious what it is. I mean, for add, it doesn't matter, right? Add,
because as we start adding a bunch of different things in here, then basically, as long as we put in, what is this, 1, 2, 3, 4, 5, 6, 7 operators, this will execute. Even though this is very, from a human standpoint, pretty not unparsable.
Yeah.
I get it.
Exactly.
Okay. I'm with you.
And this is, if you're looking at, so this is actually the underlying model for WebAssembly is this stack machine. And the reason, we're able to do a compiler in a tweet was we're leveraging the fact that the expression language that we accept has the exact same computational model as WebAssembly, right? It would have been much harder here if we wanted to have expressions that look like I mean, not much harder, but it probably wouldn't have fit in a tweet, I guess, is the thing.
Right.
If we wanted to have, expressions that look like the ones you learned in math class.
Right, because we need to understand like parentheses. We would need to understand the order of operations so that you could say like go find everything that's division and multiplication first, and then do the stuff that's addition and subtraction.
Exactly.
And it's not necessarily harder. It's just more cycles.
Yeah, and I mean we would have probably built a tree and then had to walk the tree. This is where you get into, in compilers, things like abstract syntax trees and things like this. And we've done something that's so simple here that,
I do love a good abstract syntax tree. That's one of the only low level things I actually understand. So I always get excited because I get like pretend like I know what's going on.
I mean, now you understand a lot more low level stuff, right?
Yeah, I mean, this is very cool that this is kind of working the way that it's working, because again, for everybody who's maybe just tuning in now, like the only thing we've got in here is this is the program, and we are putting in the length for like how many instructions are being added, and our list of instructions, which is being built right here. That's very cool. It's just very cool that this works the way that we expect it to, despite being very little actual code. And because I think the other thing that's important about this is like when we run addition in JavaScript, we're not performing the addition, right? We're sending like the symbol of addition in JavaScript that then has to be compiled by the browser into something like this that says, hey, browser, do the addition, And if you ever look at like how JavaScript breaks down, if you look at the way a parser or a compiler works, it's not, this is not very much code, is I guess what I'm getting at. And so this is very cool that you can get this much going, and that, now that we've been doing it for a little bit, and I know that I ignore this block, things aren't as opaque as I expected them to be. Like, I mean, let me walk away from this for more than 30 seconds and it'll all immediately exit my brain. But like, it's cool that having looked at this for a bit, I'm like starting to understand how different things fit together.
Yeah, nice. So maybe
we got about 15 minutes left on the clock. Is there are there any specific things that you think would be like really good to dig into for this last little stretch here?
Well, I thought one thing that's interesting to talk about is, how you can actually affect the outside world with WebAssembly, right? We're doing something here which is very, okay, we're just calculating a number, and it's a little bit hard to make the leap from that to understanding, how does Figma do useful things with WebAssembly in their app. And yeah, we can begin by talking. I also have a demo we could look at, and we could jump into it in the debugger again too. But yeah, just briefly, basically, when your WebAssembly module, if you want to be able to affect the outside world, or affect even sort of the browser world, right? There's really only a couple different ways they can do that. One of them is imports. So when we create the module can declare that it imports something. So even as something as simple as like printing to the console, right? WebAssembly cannot do natively. So if we want to print to the console, you need to import, you need to say, I need a function called console.log or print or whatever you want to call it. Go ahead.
Well, I was just thinking, like, what would it take if we're, we've got our math function here. If we want to have it like ask for an argument. Maybe that's more than we want to get into. Being able to like pass things in and out to say like, I want to run this add function from the module that I wrote, but I actually want to use it in a JavaScript file.
What do you mean?
Well, I guess we're doing that here, where we're doing this is our Wasm thing. So maybe you just answered my own question, so I'm going to let you keep talking.
Sure. So we can import. So one of the ways that we can sort of get access to do interesting things, like fetch is maybe a more interesting example, right? You might have a WebAssembly module that wants to be able to actually make a network request, right? Mm-hmm. We need to basically give it the capability to do fetch. So if you scroll down to where we instantiate the module, so where we have return WebAssembly.instantiate, the idea is that if in the binary encoded module, it said, I import a thing called fetch, then when we instantiated the module, we would have to give it fetch. It has no way of knowing that does what it thinks it does, but we give it a thing that has a name that it asked for. Mm-hmm. So that's kind of the most basic way of doing imports, of like affecting the outside world. Okay. The other thing that a module can do is modules can read and write a protected area of memory. Mm-hmm. So when we create the module, one of the things we can do is say, hey, it needs memory. And we can say we can even say how much memory it needs. And what we can do is to actually write, this is like old school 8-bit console programming or something used to work this way. You want to render something to the screen. Here's an area of memory. Write some bytes into it, and we will display those on the screen for you. So you can use a pattern like that as well.
Got it. Okay, I'm with you. And so the way that, and can you do that? Do you have to allocate the memory ahead of time, like when you write the program, or is it the sort of thing where if I'm gonna upload an image and I want to run some kind of processing on that image, I can tell the WebAssembly program, like, you're going to allocate memory, and the amount of memory you're going to allocate is, let me get the size of this image and send that as part of my call. And it says, great, I'm ready for an image that's this big. And then you pass that in and does the processing. Or is it more like, yep, I can accept up to this many bytes and you have to pad it out or something?
I mean, you could do both. So basically we can from the outside, we can grow the module's memory for it. So the general like idea is you assume the program on the outside is like the controller, right? So and the program on the outside here is just our JavaScript code, and it can it has the ability to. It's in the end the one that's going to give the module its memory, because you can import memory much like you import a function. And the JavaScript code can also say, oh, I'm going to grow your memory for you. But the module can also itself request to grow memory. And that will just happen automatically then. So you can kind of do it both ways.
Okay. Cool. Okay. So, very cool. So
maybe a quick demo if you go back.
Yeah, I'm guessing we don't have time to build it. So let's go look at it.
Yeah.
Okay.
And if you just change the URL here and add /canvas, so /JSON/canvas.
This is very like WebGL-y.
Exactly. Yeah.
Okay.
What this is two different WebAssembly modules that are basically responsible for not rendering the pixels, but deciding on the values, the colors that those pixels should have. And one of them is working just like I described by writing to memory. And basically on the JavaScript side, we have request animation frame, and every frame we read the memory and then stuff it into the canvas's image data. So yeah, we could look at the code if you want to see like what that looks like from the JavaScript side.
Are we looking here or are we looking on?
Somewhere? Under sources.
Sources.
Or yeah, you could click on the app.js too. Yeah, it's in here.
Whoops.
So yeah, so you see the draw screen there.
Mm-hmm. Okay, so draw screen calls draw, which comes out of the setup export.
Yeah, so basically that tells the WebAssembly module it's time for you to draw a frame.
Mm-hmm.
And after the WebAssembly code has run, we just take whatever it wrote to memory and stuff that into the canvas. So yeah, this Wasm setup export function is interesting because it shows us the module is actually exporting its memory. That's what mem is.
Mm-hmm.
And then on the JS side, we're using... So on the JS side, you can access a module's memory, again, just as a big typed array.
Right, and so drawing the pixel. So this is very similar to like WebGL, where we're getting like the red, green, blue, and alpha as like a four byte value, and then we've got a Y value and X value. And I'm assuming the way that this is working is it's basically saying you've got a space of say 200 pixels by 200 pixels, loop through this, and for each pixel, 0, 0, 0, 1, all the way through to 200, 200, calculate a value, and then you can use its current position and time and whatever you want to sort of modify that value.
Exactly. Yeah.
Okay. So that part, if you want to see how that part works, back to older episodes of with Jason on drawing in the canvas. There's some WebGL stuff. There's some other, like a really good one with Char Styles where we do some visualizations of music that get way more into how the visualization part of this works. And then on the WebAssembly side, what we are seeing here is that you've been able to offload all of that work into the Wasm file.
Mm-hmm.
Got it. Okay.
And that could be on a worker. You could have a web worker that's actually running that Wasm if you wanted.
Mm-hmm. Yeah, there's a lot going on here. This is extremely cool. So I know we barely have to scratch the surface, but I mean, unfortunately, we're out of time. So I want to dive into really quickly showing everybody additional resources. So let me. First, I'm just going to link back to your book again. So this is the book on From the Ground Up. You co-wrote with Mariano. We've got a discount code set up. If you use the discount code Jason, you can get a discount on the book. Are there any other resources that you recommend for people if they want to dig in and learn more?
Yes. So the MDN documentation on WebAssembly is really good.
I should have spelled that right. Yeah, here we go.
Yeah. WebAssembly.org is a site that is run just by the WebAssembly community group, has a bunch of resources. If you get into the point where you're sort of curious about upcoming features and things like that, this is a good place to go.
Yeah, I see like specs and feature status. That's all useful if you're wondering. Very cool. And then anything else?
I mean, people can find me on Blue Sky and Mastodon, or find me at Dubroy.com. And my Blue Sky is also Dubroy.com.
Cool. Let me get your actual website going here. There we go. And
I'm lucky enough to have a uncommon name.
Yeah, that's me too. I'm one of one of the Jason Langsdorfs in the world. Okay, Patrick, thank you so much for taking some time with us today. This was super fun. I'm always really grateful when something that feels so intimidating you just get somebody to kind of walk you through the first steps. So if this is any indication of what it's like to kind of learn the rest along with the book, I think that is that's a good time. I'm looking forward to seeing how people maybe try to incorporate this a little bit into their lives and see what kind of cool work you can do if you're not forced to do it all directly in JavaScript or ship everything off to a server. Any words of wisdom for everybody before I take us home?
I don't think I have any words of wisdom. Sorry.
Well, thank you very much. A lot of fun. Thank you to everybody watching. As always, please like, subscribe, share this with somebody. We are always looking for new people to come on the show. So if you or someone you know is working on something cool, please do hit us up and maybe we'll do an episode of Learn with Jason. For now, that's all we got. Thank you so much. And we will see you next time.